Shri Gurubhyo Namaha, children. We welcome you for our online teaching academy, Ekalaiva. Today we are going to continue with 12th Standard State Board Physics, chapter number 4, Electromagnetic Induction and Alternating Current. Today we are going to discuss energy conversion during LC oscillation. So that is our topic today, right? So this is the diagram to study the energy conversion during LC oscillations. Now we know that energy can be stored both in an inductor as well as capacitor. In inductors, now we store the energy in the form of magnetic field, which is given by the equation UB is equal to Li square by 2. Now this represents energy. Now this is stored as magnetic energy in inductors. Okay, and also in capacitors, energy is stored and the value of energy is given as UE is equal to Q square by 2C. Okay, now here this energy is called as electrostatic energy. Electrostatic energy, whereas here you call it as electromagnetic energy. Okay, now we are going to use these formulas to study the energy conversion in LC oscillations, because we are going to have a circuit which is having a capacitor and an inductor. Look at this diagram. Now here is a capacitor, here is an inductor. Okay, so they are connected, and whenever energy is given to this circuit, which contains an inductor whose inductance is L and a capacitor whose capacitance is C. So when energy is given, what happens here is the energy, it oscillates back and forth. That is, the energy oscillates between, here we have electrical field, here we have magnetic field. So the energy oscillates back and forth between the magnetic field of the conductor and the electric field of the capacitor. Okay, so this is an inductor. Now here the energy is oscillating between the magnetic field of the inductor and the electric field of the capacitor. So what happens when energy is oscillating? You have electrical oscillations. Okay, electrical oscillations are produced which will have a definite frequency. So these oscillations are nothing but, you call it as LC oscillations. So how these LC oscillations are generated? Okay, so that is clearly understood from this diagram. So the concept is well explained in this textbook. So each and every case we are going to discuss now. There are cases from, now it starts from A, 1, 2, 3, 4, 5, 6, 7, 8 cases we are going to discuss. Okay, so let us move on to this first case, which is case A. Now here the capacitor. Now we know that the capacitor is a device which is used to store electric charges. Okay, so here we assume that the capacitor is fully charged. Now here there are two plates, parallel plates. Now this plate is positively charged, and here you have negative charges, right? So this capacitor is fully charged and it has got maximum charge QM, okay, at the initial stage. Okay, so the energy stored in the capacitor. Okay, so let me write here case A. Okay, so what happens in case A? Now here the energy is stored in the capacitor is maximum. So the energy is given as UE is equal to, now here we have the formula I have already written, Q square by 2C. So this will be QM square because the energy is maximum, the charge is maximum here. So UE is equal to QM square by 2C. Okay. Now here capacitor is fully charged and there is no current flowing in the circuit, and the inductor, as there is no current flowing in the circuit, the energy stored in the inductor is 0. Okay ma? So what will be the value of UB here? UB will be 0. Okay ma, because no current. So the reason is no current flow is there in the circuit. So UB is 0. So what will be the total energy here? So the total energy will be wholly electrical. Total energy will be the sum of these two. Okay, electric energy will actually it is electromagnetic field, and here electromagnetic energy here, electromagnetic energy, and here it is electrostatic energy. We can simply say it as magnetic energy and static energy or electric energy. So here the total energy will be wholly, that is fully electrical. Why it is fully electrical? Because there is no current flow, so there is no energy stored in the inductor due to the magnetic field. So here when we consider the total energy, it is only due to the energy that is stored in the capacitor, which is completely electrical. So the total energy will be wholly electrical, which is represented in this diagram. And there is a graph they have, there is a comparison between the two energies. One here, this is UE, which represents the electrical energy stored by the capacitor, and here it is UB, which is magnetic energy stored in the inductor. So magnetic energy, as far as this diagram is concerned, it is 0. Okay, so we have maximum electric energy, and the total energy will be wholly electrical, which is represented by this graph. Okay, is it clear? Yes, right. Next, we are going to the next case. Now what happens? Now when this is connected, now the capacitor slowly it starts discharging. Okay, here it is fully charged. Now when it is connected to an inductor, now what happens? The capacitor it starts discharging. Okay, and the charges they start moving. Charges in the sense here it is negative plate, we talk about electrons. So the movement of electrons takes place, which is from the negative plate to the positive plate, and the current will be from positive to negative. So look at the direction of current here. Okay, so the capacitor starts discharging and there will be a current flow in clockwise direction. Now this is clockwise direction. So when there is a current flow, definitely this current excuse me children, this current will produce a magnetic field around this inductor. Okay, and now there will be energy stored in the inductor whose value will be definitely Li square by 2. So here also we have some energy, and here also we have some energy, but here the capacitance, the charges, it starts decreasing because a current is produced in the circuit, and you have magnetic field produced in the inductor due to the flow of current. So the charges in the capacitor decreases, the energy stored in it is also decreasing. So the total energy will be here. So case B. So case B, now you have the energy due to capacitor. Now here I cannot, in first case I wrote the charge is maximum, but here I cannot write the charge to be maximum because we know that the charge is decreasing, right, due to the current flow. So it is Q square by 2C, and this time we have magnetic energy which is given as Li square by 2. Okay, so what will be the total energy now? The total energy will be the sum of electrical energy, and magnetic energy. So this will be the total energy with respect to case 2. So that is represented here. Okay, so 50-50 here. Now UE also is there, UB is also there. Okay, now let us move on to the third. So what is happening here? So here the charges, it starts decreasing, there is a current flow and the magnetic field is produced in the inductor. Okay, so this is the second case. Now what happens though? The process goes on. So now here, now there comes a stage where there is no charge in the capacitor. The completely here the charge pathina no charge here. Okay, so all the charges are transferred and here the inductor gains energy. That is, the energy is fully transferred to the magnetic field of the inductor. Now we have the energy of the inductor to be maximum. Okay, and there will be a maximum current that is flowing in the circuit. Here the current is not maximum, but here the current is maximum. Okay, and charges in the capacitor are exhausted. That is, there are no more charges here. Okay, so now in case 3, the maximum energy, case 3 or C, you have UE to be equal to 0, UB to be having maximum value. Now here L, now I, actually here also it should be Li square, children, right? So Li maximum here, okay, divided by 2. So here you have maximum current flowing in the circuit. Now the total energy will be, okay, total energy will be wholly magnetic. Okay, so this is case 3. Clear? Now let us once again recall. Now first you should understand this 3, then you can understand other things very easily. So first here the capacitor is fully charged, there is no current in the circuit. Now energy in the inductor is 0 because there is no current. So the total energy will be wholly electrical. Okay, then second case, the charges in the capacitor, it starts decreasing. There is a current flow in the circuit and you have magnetic energy that is created due to the current flow in the inductor. Now the energy is due to both electric field, the electrical energy as well as the magnetic energy. So you have the total energy to be the sum of electrical and magnetic energies. Now here is the third diagram where the charges in the capacitor gets fully exhausted and the charge or the electrical energy becomes 0 here. You have maximum current flowing in the circuit and we have the energy completely getting transferred to the inductor and the inductor gaining maximum energy, which is given as UB is equal to LIM square by 2 and the total energy here it will be wholly magnetic. Is it clear, children? You understood this. Now we are moving on to the next case, which is case D. Okay, now what is the process? Now we know that the current is moving in the clockwise direction. Now here also the current direction is in the same direction, but this time what is happening now? Now here the charge in the capacitor is 0, right? Here in this position the charge in the capacitor is 0, but still the current will continue to flow in the same direction. The direction of current will be the same. Here it comes like this. Look at this direction. Now clockwise it comes in the, it is not changing. The current flow is in this direction, same direction. So what is happening here? Now here the current is made to flow. Now here you have maximum current, but when it is flowing here, the direction, the value of current or the magnitude of current will be decreasing. Okay, because the magnetic field here will start collapsing. The value of current which was maximum here, it now starts reducing, which charges the capacitor. Now this time the capacitor is once again getting charged. Now here the magnetic energy being converted into electrical energy, and here the capacitor is getting slowly charged, but this time it is getting charged in the opposite direction. Okay ma, so here current after this it is decreasing, it charges the capacitor in the opposite direction. Okay, so a part of the energy is transferred once again from inductor to the capacitor. Okay, now here the total energy will be again, now this fourth case you have case D. Okay ma, you have electrical energy also which is given, and magnetic energy also it is there. So you have once again Q square by 2C, and here you have Li square by 2. So the total energy once again here it will be the sum of what? Electrical energy plus magnetic energy. Okay, hope you would have started understanding the concept now. Now what will be the, now here again it is represented, again it is 50-50 here. You have both electrical energy as well as magnetic energy. Okay, but here in this case no electrical energy, only magnetic energy. So this is maximum. Okay, now let us move on to case E. Now what is happening? In case E, current in the circuit is reducing and it reaches 0. Okay, now here current is reducing, again the process is going on. At a particular stage, current value becomes fully 0, which charges the capacitor. Prepare here, you look here, capacitor is fully charged. Okay, but this time it is fully charged but in the opposite direction. Compare this with to this. Now here positive is in the upper plate, negative charges are in the lower plate, but here positive charges are in the lower plate and here negative charges. So they have, capacitor is charged in the opposite direction. Okay, now we have the maximum energy stored in the capacitor, whereas in inductor there is no energy because there is no current. The energy stored in the inductor is 0. The total energy is once again wholly electrical. So this is case E. Okay, case E, you have maximum electrical energy. So UE is, again this time I will have Qm square by 2C. UB will be 0. So total energy will be wholly electrical. Okay, clear? Now look at the next diagram. What is happening here? Now again the same process will be repeated. Now whatever we started here, we have reached to the opposite, exactly opposite. Now once again the process will be taking and will be coming, finally reaching this position. Now look at this diagram. Now what is happening here? Now here again I told you to explain, I forgot to explain you this. Again here we talk about the electrical energy to be complete, magnetic energy to be 0. So the graph will be like this. Okay ma? Now the state of the circuit, again it is initially the same, but the difference is the capacitor is charged in the opposite direction, right? Now this diagram, what is happening here is, now once again the capacitor, now it starts to discharge. Okay, now it starts to discharge through the inductor. Now the current has changed the direction. Now it starts moving in the anti-clockwise direction. Direction of current, you see, now from here to here, the current direction is clockwise. Look at the direction of current. I is 0. I is moving this side. Maximum current here the same. The direction of current is same. It is moving in clockwise direction. But here it starts because positive charges are here. Okay, conventional direction of current is from positive to negative. So the current direction is changing. Now it is moving in the anti-clockwise direction. So anti-clockwise direction, now you have decrease in charges, current flow will be there, and you have energy stored in the inductor. So as far as case F is concerned, now let me write here case F. You have both electrical energy, which is given as Q square by 2C, and magnetic energy, which is given as Li square by 2. So here what will be the total energy? The total energy will be once again the sum of electrical energy plus magnetic energy. Magnetic energy. Okay, ma? So this is case F. Okay. Now what is happening? Look at this again. Again the current still moves in the anti-clockwise direction. Now here once again the process is the same repetition. Now again the energy is maximum here in inductor. You have maximum current that is flowing in the circuit. Okay, and the charges in the capacitor becomes completely exhausted, and the energy in the circuit is only due to the magnetic energy. So here in case G, you have case G, you have UE to be 0, UB to be LIM square, because current is maximum. So the total energy is wholly magnetic. Okay, right. Now we are moving on to the last case, which is H. Now what is happening here? Again the electrical energy here, it starts getting exhausted. Still the current is moving in the anti-clockwise direction. So since the energy in the inductor is decreasing, which makes the capacitor getting charged. Now here in this case you have both magnetic energy as well as electrical energy. The capacitor is getting charged. Once again positive charges are getting accumulated in this plate and negative charges are getting accumulated in this plate. Current flow is in the anti-clockwise direction, and you have the total energy to be the sum of electrical energy and magnetic energy. Okay, so this is case H. Okay, so UE is equal to, you have Q square by 2C, and UB is equal to Li square by 2. So the total energy will be the sum of electrical energy plus magnetic energy. And finally once again, now here there will be no current and the capacitor getting fully charged. Now so what is happening here is the process is repeated, and you have electrical oscillations that are set up because one energy is getting converted to another energy. You have energy getting transferred between the electric field and the magnetic field, which produces oscillations, electrical oscillations of well-defined frequency, well-definite frequency. Electrical oscillations are generated. So these oscillations are nothing but you call it as LC oscillations. Okay, so whenever there is no loss of energy, now these oscillations will continue to happen indefinitely. So these type of oscillations are called as undamped oscillations, because in an ideal LC circuit there is no loss of energy. So one energy will be getting converted into another energy without loss of any energy is nothing but you call it as undamped oscillations. Okay, is it clear children? So this is about energy conversion during LC oscillations. Okay, so we'll be continuing with our next topic in our next video, children. To subscribe for our YouTube links, please press the subscribe button and you will be receiving our latest updates. Thank you, children.